Hi, everyone. I'm Gabi O'Connor, and I'm so excited to talk with Aditya Bhargava today about his book, Grokking Algorithms, an illustrated guide for programmers and other curious people. I've known Aditya as a coworker at Etsy, where we have both worked as software engineers, as a friend and talented amateur ice cream maker. But only as I've been preparing for this interview have I also come to know him as an incredible author. I'm so impressed by his ability to articulate these dense and somewhat abstract concepts that can sometimes be the bane of an aspiring engineer's existence. I wish I'd had this book when I was just starting to learn how to code, and I'm so glad to have it even now as a resource if I interview for a job in the future, and honestly, just to geek out about algorithms and elegant problem solving. So without further ado, let's talk to Aditya. So why don't you tell everyone a bit about yourself and what this book is about?
Sure. So I'm Aditya. I'm a software engineer, and this book is Grokking Algorithms. I have a copy over here. It is an illustrated book on algorithms, and it's meant to be easy to read.
So how did this book come about?
Well, it started, I had a blog where I was illustrating concepts from Haskell. Haskell is a programming language I enjoy working with. And so I had a few blog posts on there, and Manning, the publisher, saw those and contacted me and invited me to submit a proposal for a book. And I have always wanted to write a book on algorithms. I felt like that was kind of a gap because I think algorithms are very interesting and cool, but they're often hard to read in the more academic books. And so I submitted the proposal and they liked it.
Nice. So yeah, like you said, there are plenty of algorithm books. What makes this one different?
Like I said, it's illustrated, it's easy to read. And a big part of that is I have included a lot of very concrete examples in the book. So, for example, I have an example in the book where I'm using a mango seller. You're trying to find a friend who's a mango seller. Another example, you're going with friends to a movie theater and you're trying to figure out how to sit together in the movie theater. What I've done is I've picked a very curated set of algorithms and kind of focused on quality over quantity. So, with the smaller set, I'm really able to focus on providing more examples for each topic.
Yeah. I think from my reading it, the thing that really stood out to me was your use of illustrations to illustrate these concepts and like art and funny, realistic ways of depicting some of these concepts. So I'm curious how you came to that approach and what you find effective about it.
Yeah, it's a good question. It's an approach I have been using for myself for years. It's connected to this idea of a memory palace where you, I think like medical students use this a lot, where it's so hard to remember all this different terminology. But if you have a concrete thing and you tie abstract concepts to it, then it's a lot easier to remember. And I have been drawing for years. So it was very natural for me to tie abstract concepts to, little drawings that I make. Like I said, I started sharing that with these blog posts. And one of my blog posts, it's about monads, which is a very difficult topic in Haskell. And it became very popular, and it's still my most popular post. But when it became popular, that's when it felt like probably other people would benefit from this approach.
Yeah. Why did you choose, or how did you choose these algorithms, the ones that you included in the book?
It's a good question. Like I said, I picked a very curated set. So it's not, it doesn't cover as many topics as the MIT Introduction to Algorithms book, for example. I picked the algorithms that I myself find to be useful for my work, that I find myself reaching for frequently. And, really the book is about problem solving. So I picked algorithms where if I have a problem at work, I could reach for one of these algorithms and solve it. And so, again, I focused on a smaller number of topics, spending more time on each topic.
Nice. Very cool. So you mentioned a little bit earlier that you were interested in algorithms from kind of an early age. What is interesting about algorithms in your mind?
It's really interesting to me how creative you can get with them. I code a lot in my free time, and it's always surprising to me where I end up using one of these ideas. So, for example, I draw. Obviously, I've been trying to get more into drawing like comic strips. I really enjoy comic strips. Like I used to read Calvin and Hobbes, years ago. And one tedious part about it is drawing the panels. It's so finicky. You spend so much time doing the measuring. And so I wanted to write a little app for myself that would draw the panels for me. Something easy that I could say, like, I want 3 rows of 2 boxes each or whatever. And while I was making that, I realized the easiest way to model that information would be as a binary tree. And even today, I haven't found a better way to model that. And it's just so surprising, right? Because there's such disconnected areas of focus. So I think that's what I really enjoy. It's not like learning a language where, you might be using a different language 10 years from now or something. They're very basic ideas. They're very human ideas. I often talk about these ideas to people who know nothing about computers, and they are still able to understand them because they're such fundamental ideas.
Yeah, I also noted that when I was reading this book that my husband, who is a writer and not technical or not an engineer, and I often struggled with talking about my work and creating analogies to describe, what the work is and kind of put it in layman's terms. And I thought your book did a really great job of being able to illustrate these concepts, like literally illustrate these concepts, but in ways that can make sense to anyone at any stage of their engineering experience or even non-engineering. So yeah, I thought that was great. And I totally agree. So what in your mind are some key takeaways from the book?
Well, like I said earlier, I think this book is really all about solving problems. So I think my key takeaway is if you're stuck on a problem at work, try one of the techniques in this book. And I guess to even refine it more, my number one piece of advice would be if you're stuck on a problem, try using a different data structure. It's really amazing how many problems can be solved by just using a hash table or using a graph.
So shifting gears a little bit, I think you touched on a little bit earlier, just the joy and the creativity in algorithms and coding generally. What in particular do you find creative about coding?
It's cool to make those surprising connections. And I find that the more I know, the more I'm able to make those connections. And, like I said earlier, I do feel like it's a very human field, even though, it is computers. And just to give a quick example, one of my early chapters is about binary search, which is a very common technique used for speeding up search. And of course, no one outside of computer science would know about this. But, if you just try this simple trick, and I'll just do it now, and maybe, viewers can try themselves, or they try it on a relative or whatever, and tell people, I'm thinking of a number between 1 and 100. Guess what it is? And they might take a guess like 37 or something. And then I'll say, sorry, that's too low. And then immediately their next guess will be something like 65 or 70. They're not hearing that's too low and then saying, 38. Because all of us instinctively, as soon as you hear that's too low, you know that you need to cut the remaining search space in half. And so maybe they say 70, and then I say, oh, that's too high. And so now they know the number has to be between 37 and 70. So again, they're not going to say 69. This is sort of a longer example, but just to say it is just so human to do this. And it's so cool to be able to keep making those connections every day.
Yeah, I totally agree. So how do you find joy in coding at work?
I try to work in areas that I don't know a lot about. I find that it forces me to learn new things. And a lot of the joy I get, again, is like seeing those connections, seeing how different parts of the system work together. If I know a lot about the back end at a company, I find it interesting to work on the front end, or maybe work on the big data stack, or try to take one component and optimize its performance or something. I find, that keeps things fresh and also like keeps surprising me with new cool things about coding.
You talked about how this is your first book and that you transitioned from writing blog posts to writing this book. We've talked about this before, but I have so I'm a career changer. I was a teacher before I was an engineer, and I used to also teach programming to high school students as like a volunteer program. And I was curious about what you learned about teaching during the process of writing this book.
That's a good question. I should also mention I'm a career changer too. So we're both career changers, and we've talked about that a little before. It is nice to have that different background. I feel like, I bring something new to my job, and that, I'm sure you feel the same way. One thing I've learned about teaching is I find it very useful for me when teachers don't skip any steps. They show things, they show every step of something. And I had an algorithms teacher who did that, who would, literally take an algorithm and walk through what it's doing to an array for every element in the array. And I found that to be very useful. I kind of want to make sure that, like, if I'm skipping a step, that means I'm like leaving space for a reader to have a question that's not answered by the book. And so I try to avoid that. But mostly, I think the repetition really helps because it helps me read something, think, oh, I think I understand it, but I want to check, and then see it again, and then feel like, okay, I do understand it. So I do a lot of that in this book. For example, I have this whole section on recursion where literally I'm going through a snippet of code line by line, and on each line I'm saying, here's what the stack looks like now. Here's what the stack looks like now. And I find that that's a lot more helpful to me than just saying, when you call the function again, you're adding a call to the call stack.
Nice. And we talked a bit earlier about, using the use of illustrations in this book. How do you feel that these illustrations can kind of support the methodology that you were just describing?
It's a different check on your understanding, right? Because you've maybe read the text, but seeing the image helps you confirm whether you've understood it or not. So very often in the book, I will put something in text, and then I'll also illustrate it. And maybe I'll illustrate it 2 or 3 different ways even. So I think it plays a good supporting role for the text. There are parts of the book where I really rely on the illustrations primarily to explain something, because there are things where it's either easier to understand or it's more satisfying. So I have this whole section on divide and conquer. And divide and conquer, that means you have a problem, you break it down into smaller and smaller pieces, and you solve those pieces, and then eventually you solve the whole problem. And that I can write that in text, but it's a lot more satisfying to me as a reader to have a rectangle, for example, and cut it up into smaller rectangles and show all of these smaller rectangles being finished, and then kind of show like now the whole thing is done. There's just something deeply appealing about that kind of explanation to me.
There are other algorithm books that have like graphs and diagrams and different kind of visual aids, but yours is the first book I've read where some of these ideas are illustrated with cute animals and people and jokes about Seinfeld and a lot of different ways of communicating these ideas. And I'm curious if you have any thoughts about why why that is, why maybe there isn't more art in some technical books.
I think the most likely answer is people sometimes don't feel confident about their drawing skills. I do think that's changing because truly, you're not drawing like a realistic person or something. It's very easy to just draw, circles and lines and explain something in that way. So yeah, I think it's maybe lack of confidence in drawing ability, but I would really encourage people to draw more.
Yeah. Do you have any, suggestions for people who want to get better at or think about, creating analogies for these abstract ideas? Like any tips that you have for people trying to get better at this?
Yeah, I do have a few tips. First, I'd say the analogies, the examples are the core of the writing. So just expect to spend a lot of time on them. Truly, these chapters, the number of times I went back and forth with my editor where we'd come up with an analogy. I'd even do some of the illustrations. And then we'd say, no, this doesn't really feel, this doesn't work that well. So just be prepared to think through several different analogies. And then the other thing I'd say is talk to multiple people, explain your idea to both technical and non-technical people and see what they think. And, part of it also is, like you said, I have a lot of Seinfeld episodes in the book. I have a lot of different Easter eggs. I wanted to write a book that would feel interesting to read. So, it's not just about conveying information. Every chapter, I wanted to feel like, okay, I want to read this chapter. This feels like interesting material to me. And so that's something to look for. If you are talking to, I talk to my wife about ideas all the time. And if I can tell she's just bored about talking about this, then I don't want to put that idea in the book. I don't want to put a boring chapter in the book.
I kind of have a tip too, I think, for people who are trying to improve these creative skills, because it's been something I've been thinking about a lot recently myself. I think that sometimes it can be hard to create if you're afraid of messing up. And I think that a lot of us who kind of are high achievers are a bit of perfectionists. And so I took a workshop recently about drawing imperfect portraits. And I think one tip was just use paper and don't be afraid to use up the paper. The paper's there. It wants to be used. And I was like, that's true. You can just use it. And it doesn't have to be perfect. I also took at a tech conference in, the before the pandemic, I went to a improv for introverts workshop. And the whole idea was kind of letting loose of trying to be perfect or trying to be living in the moment and not being so anxious about things going perfectly. And I felt that was really helpful too. So maybe there are things like that people could look into in their areas, or just don't be afraid to try new things and to fail at them.
Yeah, I think that's a great point. I guess to add to that, I have been getting more into digital art. I've sort of just done traditional in the past, but I got an iPad, I started using Procreate. And so I started watching videos on YouTube of artists that I admire drawing, painting something in Procreate. And it's just amazing how many times they start over on something. And it really helped me feel like, okay, they did this kind of stunning piece of art. They didn't just sit down and draw every line perfectly. Often they'll do a whole sketch and they'll even start coloring, and then they'll say, I don't like this. And they'll because it's digital, you can reduce the opacity or something and use it as a reference for the new thing you're drawing. Or sometimes they just erase it completely. So yeah, don't be afraid to start it over. Yeah.
You can't improve if you aren't afraid to fail on occasion and learn. That's how you learn. So was there anything that you know now that you wish you'd known when you started writing this book?
I wish I had known how long it was going to take. I think I would have still done it. I'm really glad the book exists, and I get emails from people saying how much they like it, which is always lovely. But I think when I started, at Manning, they had said at most these books take a year and a half. It'll probably be done in a year. And it took more than 3 years for the whole thing to be done. And just part of that was we did keep rewriting so much. I mean, the dynamic programming chapter took 5 months because we would keep doing the chapter thinking, okay, it's done. And then feeling but it's not explaining it well enough. I mean, dynamic programming, I find very hard to explain well. And so I think I would have been more ready for that experience.
How did the length or working on this project for so long compared to working on long projects at work?
Well, this is definitely the longest project I've worked on, but I do think, they feel similar in that you don't want to think about the whole project at once because it can feel daunting. And so it's good to break it up into smaller segments. And so, of course, with the book, I did okay, I'm working on this chapter and I'm not going to think about the other chapters right now. And at work, I've, worked on some projects that have taken more than a year. And, we've just done milestones. And often it does feel, even with this book, it felt like, oh my gosh, this book is never going to end. This project at work is never going to finish. But having those milestones really helps me see that I'm making progress.
We may have come to the end of the questions that I had about this book, but I wanted to see if you had anything else that you wanted to share for people watching this or people who are interested in reading your book.
I would just leave you with algorithms are fun. They can be fun. So I hope you find some joy in this book or in algorithms in general.
Yeah, I definitely finished the book and was like, okay, I need to look into these things more, of the concepts or further reading that I didn't know of. And I'm also inspired to start creating more creatively, illustrating. Thank you for your time, Adit. It was great speaking with you.
Thanks, Gabi.
Bye.
Subscribe to the GOTO YouTube channel now and join the experts in person or online at any upcoming GOTO conference using the promo code Book Club. Visit gotopia.tech to learn more.